In this video, we're going to be talking about inequalities, specifically how to solve inequality equations. But before we get there, let's start off with a warm-up problem where we have a graph and we have to write it in inequality form and interval notation. Now, we're more used to taking a graph and changing it to an interval, so let's do that first. But when I look at a graph like this, I notice there's a solid dot at 0, so it's starting at 0, and it's pointing an arrow towards infinity. So I notice that this x is between 0 to infinity, positive infinity, so I'm going to put a bracket for the 0 since it's a solid dot, and infinity with a parentheses. Since we can never touch infinity, we use a parentheses. But to change it to an inequality form, that means you have to use those arrows, or it looks like crocodile mouths. So to do that, let's think about what numbers were given, and finite numbers. So in this case, the 0 is the number that they give us, and we want to compare that to x. So you take the number that they give you, and you always compare it to x. And ask yourself, x is this shaded region. Is x bigger than 0, or is x smaller than 0? And then that will help you determine what type of inequality to use. Now notice that x stretches away or to the right of 0. So that means that x is bigger, so you want to open the mouth towards the x. You also want to use a line underneath because this is a solid dot. So we need the line underneath it. And there you go. So basically you want to start off with a graph, get your x, and compare it to the number that it is giving you, that's the solid dot or the open circle. So in this case, you have to compare the number to 3. And so notice in this graph here, it's going from 3 to negative infinity. So x is in this region right here. So if x is below 3 or before 3, that means x is less than 3. So that means we want the arrow facing towards the 3 because it's bigger. And because it's an open circle, we don't want to write a line underneath it, and so that's it. Now to write this in interval notation, we can see it's going from negative infinity to 3. So we're just going to write it from left to right, parentheses on both since that is an open circle. And there we go. So now that we're warmed up here, let's talk about solving inequalities. So there are going to be times where you're given equations like these in example 1. I'll get my pointer, where you have to try to get x by itself, but instead of an equal sign, you have those inequality symbols. And to solve, it's very much similar like you would solve for when you have equal signs. So to do this, what you need to be aware of that is that the inequality will switch if you divide or multiply by a negative number. And I'll show you some examples so you can better understand when to switch the inequality sign. So let's just start with a here in example 1. So when I look at a, I have to get the x by itself, so I have to remove this negative 3, and this negative 3 is sitting next to the x, so I can assume multiplication. So to undo multiplication, I have to divide by negative 3, so I have to divide it to both sides. But because I am I'm dividing by a negative number, what just happened? So because I'm dividing by a negative number, that means that this sign is going to switch. And so I'm now going to be facing towards the right. So 9 divided by negative 3 is negative 3. And then these 3's cancel, so x is the only thing that drops down. And now x is by itself, so I'm done solving. So this is my final answer. Now, notice that B here is the exact same problem, only this time this is a positive 3 instead of a negative 3. So again, you have to get x by itself. So I'm going to divide by 3 on both sides. So that cancels, but notice this time you're dividing by a positive 3. So because you're dividing by a positive 3, you're not going to affect the sign on this side. And I'll explain this a little bit better once we bring down our values here. So again, I'm not flipping my signs because I'm dividing by a positive 3, and negative 9 divided by positive 3 is negative 3. And so x is by itself, so this is my final answer. So I just want us to understand, why are we switching the signs? Well, if you look on this side here, notice that the right side was a positive 9 to begin with. But when you divide that negative 3 over, it became a negative number on the right side. So that is why we had to switch the signs, because now this side is negative. Whereas this side started off with a negative number, if we divide by a positive number, it's not going to affect the negative. It's still going to stay negative. So that's why we don't need to switch the signs, because the right side sign didn't switch in the first place. So that is why, just to remember, whenever you're dividing by a negative number or when you're multiplying by a negative number, it is really important that you switch the signs. All right, let's try out some more examples here that are a little bit more complicated, like C here. Ooh, it's not moving along with it. Let's see if I can shrink it down. Okay, we're just going to ignore this weird thing going on. So for C here, I'm going to add over 30 to both sides. So that cancels. So 7x drops down. What did I forget? A 0 here? So 19 plus 30 gives me 49. And then I just need to divide by 7 to get rid of the 7. Notice I'm dividing by a positive 7, so I don't need to switch the signs. So x drops down. And 49 divided by 7 is 7. And so this here is my final answer, because x is now by itself. So x is less than 7. Let's try one more with D here. So for D, we're going to try to get the x by itself, but then where the heck do we begin? There's x's on both sides. The goal is to try to get x's by itself, so you want to try to combine like terms here. Like for instance, I notice there's a positive 1 on this side. Perhaps I can add 1 to this side so I can just have all the numbers on one side. So I'm going to add 1 to both sides, and so that cancels. And so this makes 2x plus 3 plus 1 is 4. And then 6x drops down. And so notice now I have all the numbers on one side. Maybe let's try to get all the x's on one side. So I'm going to move this 2x over by subtracting. And so that cancels. And then 4 comes down. And 6x minus 2x is 4x. And so now it looks like I just need to divide by 4. So I'm getting closer to where the x is by itself. Now also notice I divided by a positive 4. So this here, I don't need to switch the signs. X comes down, and 4 divided by 4 on this side is just 1. So it looks like x is greater than 1, and that there is my final answer. And that's it for this part of the video. In the next video, I'll talk about compound inequalities and how to solve those equations.